Hi, we can wait for some 2 more minutes so that others can also join. We will wait for just 1 more minute. So, how is your preparation for net going? Am I audible? Anyone?
Yes, ma'am.
Okay. Good evening, ma'am. Good evening. I guess we will start our session today. I'll start presenting. If the slides are not visible, you guys please tell me. Slides are visible?
Yes, ma'am.
Okay, fine. So last week we discussed about 18 electron rule and we solved some questions related to that topic. And this week we will discuss Wade's rule and then we will solve some questions related to Wade's rule that has been asked from 2013. Most of the years, at least one question was being asked from this particular topic. So I have collected all the questions, one question from 2013, 2014, etc. And then we will try to solve based on Wade's rule. So Wade's rule, or it's also called as Wade's-Mingo's rule, or polyhedral skeletal electron pair theory. So using this theory, we can find the structure of a particular cluster. So according to this rule, any boranes or carboranes, in fact, this can also be extended towards metal clusters by calculating its skeletal electron pairs, or by direct by the formula we can find out the structure. For example, in a question they will directly give formulas like B5H5. So if the formula is B5H5, it follows this group BNHN. That means it has a hypercloso structure. If it has BnHn 2 minus, it will be closo structure. So from the formula itself, we can directly get the structure. Similarly, the number of skeletal electron pairs can be calculated. The calculation is very easy. We will see how to calculate. And if we get the number of skeletal electron pair as n minus 1, where n is number of metal atoms or boron atoms, for example, if 5 boron atoms are there and you got a number of skeletal pairs, 5 boron atoms are there, and you got number of skeletal pairs as 4, then it falls under n minus 1. So it will be supercloso. So based on the number of skeletal electron pairs or the formula, we can get the structure of a particular cluster given. Now, how to apply this Wade's rule in order to find out the number of skeletal electron pairs? This is very simple based on three simple steps. The first one is determine the total number of valence electrons from the chemical formula. For example, we have B4H4. So each boron atom has 3 number of valence electron. So 3 into 4 plus hydrogen has 1 electron plus 4 hydrogen means 4. So like this we can find out the total number of valence electron, or which also can be called as total electron count. Now once it is done, we have to find out how many pH units are present. So this in here we got it is 3 into 4 plus 4. Okay. So we got it as 16. So among 16, some electrons will be used for the formation of pH unit. Each pH unit, as we can see, it is a sigma bond. So it is made of 2 electrons. So for each pH unit, we have to minus 2 electrons. And the remaining electrons we have to divide by 2 to get the skeletal electron pairs. Like if, for example, 20 is the total electron count and there are 4 BH units, then we have to minus 4 into 2, that equal to 8. So we will get 12. So 8 number of electrons are used for BH bond formation among the 20 electrons, and the remaining electrons will be used for cluster formation. So since we are seeing here what is the structure, we should know how many electrons it is used for formation of the cluster. And the number of electrons divided by 2 will give the number of skeletal electron pairs. Now, if we are extending this particular concept to metal clusters, how we can find out the skeletal electron pairs there? In case of metal clusters, similarly, we will find the total electron count minus 12 into n, where n is the number of metal atoms, divided by 2. This formula is important. So using this formula, we can find out the number of skeletal electron pairs of any metal clusters. Now, An important concept regarding Wade's rule or in solving any questions related to Wade's rule, we should know what is isolable analogy. Isolable analogy is a concept that is used in order to relate two fragments of inorganic as well as organic fragments. So, if when two fragments are told to be isolable, if they have same frontier orbitals or same energy, same symmetry or same number of valence electrons. For us, in order to solve a question, the important point is the last one, same number of valence electrons. So other 3 points we can just ignore in case of solving any calculation or any question. So how to find out which fragments have same number of valence electron? For example, let us consider BH as well as C. So we know B has 3 number of valence electron and H has 1. Similarly, carbon has 4. So 3 plus 1 is equal to 4. Carbon also has 4. So BH and C are told to be isolable with each other. Similarly, if we consider another example, iridium carbonyl thrice and CH. So here, iridium has 9 valence electron plus carbonyl is a 2 electron donor. So 2 into 3 that equal to 6. It has total 15 number of electron. CH has 4 plus 1, 5. So in any case, if we have two fragments with 4 number of electrons, 14, 4, 15, 5, like you have to consider only the last number of the total valence electrons. And if it is same in two fragments, we call it as isolable to each other. And in such cases, if a cluster is given with carbon, we can replace the carbon with BH. So this is the use of knowing what is isolable analogy. So these are the basic concepts that we should know in order to solve any question that is related to Wade's rule. Till now, is it clear or not? Because these concepts are required for solving the questions. Is
Clear,
it
ma'am.
clear? Clear, no? Okay, fine. So now we can move on solving the question using all the concepts we have learned till now. So first we will start from GATE 2013, question number 41. According to polyhedral electron count rule, the structure of RH6CO16 is. Four options are given: closo, nido, arachno, hypo. So among this, what is the structure? We should know how many skeletal electron pairs this particular cluster has. So we know what is the equation for skeletal electron pair, that equal to total electron count minus 12n divided by 2. So the given cluster is RH6CO16. Valence electrons on rhodium is 9. Okay. And carbonyl is a 2 electron donor. There are 16 carbonyls here and 6 rhodium. So 9 into 6 plus 2 into 16 will give a total electron count of 86. Now we got the first term, total electron count, minus 12n. What is n? N is the number of metal atoms. So here n is 6. So we have to minus total electron count minus 12n equal to 86 minus 12 into 6, that equal to 14. So now we got the numerator part. We have to divide it by 2 in order to get the number of skeletal electron pairs. So 14 by 2 will give us 7. So this falls under n plus 1 structure. N plus 1 is closo. So the correct option is option A, closo. Is it clear?
Yes, ma'am.
If anybody has doubt, you can stop me in between and ask. Uh, so this question, I am hoping it is clear. Moving on to next question, which is from 2014. Question number 9. An example of nidoburane from the following is. Four options are given. So first of all, let us solve each one. Option A, B, C and D separately and find out which one each structure or each cluster belongs to which structure. So the first one is B4H10. B has 3 valence electron, H has 1 valence electron. Therefore, total electron count TEC on B4H10 will be 4 boron atoms are present. So 4 into 3 plus 10 hydrogen plus 10 equal to 22. And among 22, how many BH units are there? So there are B4 boron. So 4 hydrogen will constitute 4 BH units. So each BH unit requires 2 electron for its formation, since it is a sigma bond, as we have discussed earlier. And in this particular cluster, since there are 4 BH unit, 4 into 2 equal to 8 electrons are required for BH bond formation. The remaining number of electrons, that is 22 minus 8, will be utilized for the cluster formation. So 14 electrons will be utilized for the cluster formation. Therefore, 14 electrons means the number of skeletal electron pair will be 14 divided by 2, that equal to 7. And since n here is 4, 7 means it is n plus 3. N plus 3, according to the table, falls under arachno structure. Now the second option given to us is B6H10. So in here also, similar to the option A, solving, we will get the total electron count as 6 boron atom into 3 valence electron plus 10 will give 28. Each BH fragment requires 2. Here 6 boron, 6 BH fragments. So 6 into 2 is equal to 12. Therefore, the skeletal electron pairs will be 28 minus 12 divided by 2, that equal to 8. And since n here is 6, n plus 2 will be 8 will be n plus 2, and therefore it falls under Nido structure. Now solving the next C and D. So this we will solve in a different method. This is more easy, and in this method you need not want to have any calculation. So in case of metal clusters, anyway you require to do calculation in order to find the number of skeletal electron pairs by the equation that we have seen earlier, total electron count minus 12n divided by 2. But in case of boranes, without any further calculation, we can directly get into the answer. How? By the formula. For example, the option C given is B6H12. So B6H12 can also be written as B6H6 dot H6. So in from here, if we remove 6H plus, we will get 6 minus sign. So this is B6H6 6 minus. According to the table which I have already shown earlier, BNHN 6 minus falls under arachno structure. So option C is arachno. So if we solve any question using this method, there is no need of calculation and it will save you time. So saving time is important in GATE. So you can follow this method in case of boranes and carboranes. Carboranes means boranes are clusters which have only boron and hydrogen. Carboranes means along with boron and hydrogen, you will also have carbon. So that also we will see according to along with solving questions. So option D is B8H14. We can solve according to this method similar to option C. B8H14 can also be written as B8H8H6. So removing 6H plus, we will get 6 minus sign. So B8H8 6 minus falls under arachno. So among the four, the question was to find out which cluster has Nido structure. And the correct option is option B, B6H10, and it has Nido structure. It is clear?
Yes, ma'am.
Both the methods are clear, no?
Yes,
Anyone?
ma'am.
Fine. Okay. Next, let us solve question from GATE Chemistry 2016, question number 6. In this, we have to find among the boranes and heteroboranes, the example which belongs to closed type. So I told you what is boranes. Boranes means boron and hydrogen. This is an example of carborane, which has carbon, boron, and hydrogen. Heteroboranes means it also has another element except boron, hydrogen, etc. So among these four, we have to find out which has closed structure. So similar to the earlier question we have solved, we can find the answer to this question also. The first one is B5H8 minus. Let us find out the total electron count. How 5 boron atoms are present. 5 into 3 plus 8 hydrogen plus 1. Why we have added 1? Because there is one negative charge present. If positive charge is present, then we have to subtract 1. If negative charge is present, we have to add 1. So since here there is one negative charge, we have to add 1 to get the total electron count. So thus we will get 15 plus 8 plus 1, that equal to 24. And we have seen BH requires 2 electron for BH bond formation. 5 BH atoms, BH is present, 5 into 2, 10 electrons will be used for BH bond formation. Therefore, the number of electrons left for the cluster formation will be 24 minus 10 divided by 2, that equal to 7. So here n equal to 5, and thus this falls under n plus 2 structure, that is NIDO. This can be solved with the second method also that we have discussed earlier, where we have to simply write B5H8 minus as B5H5H3 minus, and we can remove 3H plus. Thus we will get 3 minus sign. Already one negative sign is there. So 3 plus 1 negative sign will give 4 negative sign. So it will be B5H5 4 minus. And this will fall under this formula will fall under NIDO structure. So if we know the first table from the formula, we can understand that this falls under NIDO structure. The second one is C2B9H11 2 minus. In this particular case, we will need the use of isolobal analogy. We saw earlier that carbon has 4 valence electron and total pH has 3 plus 1 equal to 4 valence electron. Therefore, carbon is told to be isolobal to BH. This is the symbol for isolobal, representing isolobal fragments. Okay. So, if carbon is isolobal to BH means this carbon from the structure can be replaced with BH. So, what is the use of replacing with BH? By replacing with BH, we can directly get the formula and get which cluster, which structure this particular cluster belongs to. So here there are 2 carbon. So we have to replace BH twice B9 H11 2 minus. This also can be written as B11 H11 2 minus because 2B is here, 9B, total B11 plus 2 hydrogen plus 11 hydrogen give 13 hydrogen and 2 minus sign. This which can be written as B11 H11 H2. And if we remove 2H plus, we will get 2 more negative sign. That means the total number of negative sign will be 4 minus. So BN HN 4 minus. This has NIDO structure. The next one is GeC2B9H11. This also can be done with the help of isolobal analogy. Here also, in previous question, we have replaced carbon with BH because carbon has 4 valence electron. Germanium is also in carbon group, so it also has 4 valence electron. So carbon and germanium both has 4 valence electron and each BH fragment also has 4 valence electron, and therefore the germanium present here as well as carbon present in the cluster can be replaced with BH since it is isolobal. So one germanium is replaced with BH, 2 carbon is present, so BH twice B9H11. Therefore, the total number which also can be written as 1 plus 2 plus 9, that is 12. 12 boron plus 1 plus 2 plus 11, that is 14 hydrogen. B12H14. This can be written as B12H12 dot H2. So if we remove 2H plus, we will get BnHn2 minus. Bn2n, BnHn2 minus means it is closed structure. And the last one is B6H10. This can be written as B6H6 dot H4. Removing 4H plus, we will get B6H6 4 minus, and directly we can get that it is having a nido structure. So what was the question? The question was to find out among the options given which one has a closed structure. And since all the other has nido structure and only option C has closed structure, the correct option is option C. So this question is clear?
Yes, ma'am. Yes, ma'am.
Okay. Right. Now, the structure type and shape of the polyhedral skeletal framework of the carborane Me2, C2, B10, H10 respectively are. Four options are given. Here, there are two parts, structure as well as shape. So, structure we have seen till now how to solve it, which can be solved by Wade's rule. Okay, so this we have to find out skeletal electron pairs, or from the formula we can find out the structure type. Nido, closo, arachno, whatever it's kind. And now the second part is shape of the polyhedral framework. So that we will learn how to find out the shape of the polyhedral framework of the carborane. So first of all, let us find out the structure and then move to the second part, that is shape. So the cluster given here is Me2, C2, B10, H10. So according to isolable analogy, carbon can be replaced by BH. C is isolable to BH. The next important thing is that we have to find out the total electron count in this case. So Me2, how is Me? C, H, H, H. One electron is left. So CH3, which is Me, is a one electron donor. Okay, so CH3 can be replaced with hydrogen because this will help in getting the formula in form of BnHn. So that's why we are replacing it. We can replace it with hydrogen, and since Me2 is present, we can replace Me2 with H2. C2, B10, H10. Now, the carbon can also be replaced with BH. So, how much we will get? Here it is B10, H12 and C2 is there. C is replaced with BH. So, we will get BH twice, B10, H12. So, the total number will be B12H14. B12H14 means 3 into 12 plus 14 equal to 50. So the number total electron count equal to 50. How many number of BH units are present here? Anybody?
12.
12, correct. So there are 12 number of BH units. So 12 means 12 into 2 from each BH unit, 24. So 24 electrons are used for BH bond formation. Remaining 50 minus 24, 26 electrons will be used for cluster formation. Therefore, the number of skeletal electron pairs will be 13. Here, N equal to 12. So that's why we are replacing Me with hydrogen and C with BH, so that we can get in this formula, so that we can easily find out what is the number of N. So if we get into this formula, this will be a little bit, this might be, but total number of carbon and boron you can add, but this is more easy and you will not have any confusion if you get in this formula N equal to 12. So the number of skeletal electron pair is 13. That means it falls under N plus 1 category. So it means it is having a closed structure. Another method, I am solving every question with both the methods, so that even if you forget one method, you can use the another method. That's why I'm solving both the methods. Whichever is more easy to you, you can take that and you can solve the question whenever it is asked for GATE or NET or any competitive exams. Just you have to keep in mind that with less time, you have to solve a particular question so that you can solve more number of questions. So the other method for solving ME2, C2, B10, H10 is that similar we have replaced here. You have to replace and you will get B12, H14. That much I have explained here. So from B12, H14, this can also be written as B12, H12, H2. So if we remove 2H plus, 2 minus sign will be present. B12, H12, 2 minus. Bn, Hn, 2 minus falls under closed structure. So whichever method you solve, anyway answer will remain the same. So you can choose any method that is more adaptable to you and you can get the same answer. Now, we have solved the first part, that is structure of the cluster. Now we have to solve the second part of the question asked, that is shape of the cluster. In order to know that, we solve that, we just need to know this particular table. Based on the number of vertices, we can directly get the shape. No need of any further calculation or any other formula. From the number of vertices, shape is directly obtained. For example, this one, which we already wrote it as B12, H12, 2 minus. That means N equal to 2 here. Sorry, 12 here. 1, 2, 12 here. So the shape will be according to the table icosahedron. Therefore, the answer to the questions are structure and shape. So the structure here we got it as closo and the shape we got as icosahedron. Okay, icosahedron and loso. That is the correct option. Now, next question, GATE 2018, question number 12. If you have seen, I have taken question from 2013, 2014, 2016, 2017, 2018. In every year, at least one question is asked from this weights rule. So this is an important, like there is no much things to learn in this, just isolable analogy, the skeletal electron pair, the total, how to calculate total electron count and skeletal electron pair, how to calculate that, and the two table based on which formula as well as number of skeletal electron pairs where you can get the structure, and based on the number of vertices you can get the shape. So these things only you need. So you don't need to revise anything on the last minute based on this. Just these things you have to check and you can solve any questions related to weights rule. So this is an important concept from which you can get easy marks very easily. So now we will go on solving GATE 2018 question number 12. Based on Waves rule, the structure type of B5H8 minus. I think you guys can answer this. So what
Nido.
will be the need? Oh, so fast. Good. No need of explaining. Also, you guys are so fast. Good. I feel that you guys understood it well. Still, if somebody has some issue, I will just explain. So the total electron count is 5 into 3 plus 8 plus minus is 1, 24. I think this came in some other question also, right?
Yes, ma'am.
Yeah. So this is an important thing. This comes 2-3 times. B5H8 minus. So, okay. There are 5 BH. So 5 into 2 is equal to 10. Skeletal electron pairs will be 7. N plus 2 is equal to 7. So that the structure is narrow. Through the other method also, I will just solve this so that you guys don't get confused. If anybody still has confusion, I'll solve the other method also, where we can write B5H8 minus as B5H5H3 minus. So if we remove 3H plus, we will get totally 4 minus sign, and BnHn 4 minus means it is Nido. So either way, we will get Nido as the answer, and option B is correct. Okay. So I have told how to calculate this, but for the basic theoretical purposes, you can visit NPTEL site, classes from Professor M.S. Balakrishna. He has explained about Wade's rule in a theoretical manner also. You can see them and you can understand more. My mail ID is given here. If you have any doubt, you can ask according to you can ask to me by mail also. So you guys have any doubt, whatever I have explained till now?
No, ma'am.
Everything is clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, so I hope that if a question is asked from Wade's rule, finding out they in most of the question they give it is from Wade's rule or polyhedral skeletal electron pairs. So there is no like we won't get confusion at all. So I hope that you guys will answer any question that is asked from this particular topic, right?
Yes, ma'am.
Uh-huh. Good, fine. So what about last class organometallic chemistry, 18 electron rule? Have you tried any other questions? It is fine with you, that 18 electron rule topic? You guys were there in last class?
Yes, ma'am. Yes, ma'am.
Okay, have you tried any other questions? You have any doubts related to that or related to Wade's rule? You can ask me any questions. Think nobody has any doubt. So September 19th is net exam. You guys are solving questions, no, related to all the like topics, whatever we are teaching here, or so any questions you have found difficulty related to the 18 electron rule or Wade's rule? Okay, I find like nobody has any questions, so I think that you guys are getting able to do the questions related to this topic. Is it correct? You guys are able to do? Okay, then it is good. So I'm thinking I will give you one uh, like question which is not related to 18 electron rule or Wade's rule. It is a general question which is asked in a gate chemistry paper. So if you guys try to answer anyway, I will explain that question in the next class. So no need to worry, no need to take any tension or pressure. Just try if you can answer that question, so it will be good for you guys also. Okay. Okay. So this is the question. Slide is visible.
Yes, ma'am.
Yes, ma'am.
Okay, you can take a screenshot of this. Whenever you get time, I know you have a busy schedule because you have to attend so many classes every day. There are two classes, so you have a busy schedule. I know, but try whenever you get free time. If you feel like solving one question, you can try solving this question. You can take a screenshot of this. Anyway, I will explain it in the next class. This is not related to both the like not related to 18 electron rule or not related to Wade's rule. This is a general question that can be asked. So I thought like this was asked in Gate Chemistry 2019, question number 44. So you can just try solving it. No need of looking up on answer or anything. Just try solving. If you don't get it, it's fine. Don't worry. Next class we will solve this. But just try to do it. Okay. Have you taken screenshot?
Yes, ma'am.
Yes, ma'am.
Okay. So I will tell you this, the other one also, you take screenshot of this table. This table you take screenshot, because with this table, like when you will have some formula notes or something, no? So this table you can put it in there, and from the table you can directly get into the answer. So this table you take a screenshot, and this one is the way how to find out skeletal electron pairs in case of boranes. So this also you can take a screenshot. So this one also, which all are isolable to each other. An example, it will help you to easily like remember things. So you have learned this, you have heard this. So these materials will help you to easily remember the things. So you have taken.
Yes, ma'am.
Okay, fine. One more table was there. I'll show you that one also. That also you take. Okay. This one also you take. So both the structure and shape will be clear to you. Any questions? Questions majority is asked to find out the structure. In some question shape, but still the question is related to structure only. So if you know these tables, you will easily be able to do the question. So you guys took screenshots of everything, no?
Yes, ma'am.
Okay, fine. Any other doubt? Anything else you want to ask? Okay. So I guess you guys are clear. So it's okay. Should I start doing next question, or no? You guys try doing that question. I'll do that next week. That will be better. So I have in this session I have told 5 questions I have explained, and other years questions based on Wade's rule. You try solving it, and if you find any difficulties related to that, you can ask me. You can mail me. My mail ID was given. So any questions related to that, if you have, you can ask me that also. So I hope it's clear. So I'm here just checking the chat also if anybody has asked something. Okay, nothing. Mahalakshmi, I think she has answered one question. Neerav. Okay, good, good. Okay, so now I think if it is clear to everybody, we can uh, like end this session. If any doubt is there, you can ask further. Okay, I hope it's clear. Try to solve the questions and then let me know that whether you are able to solve or not based on both the session. Okay, is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So now I'll be closing the session, and we will meet next week. So that week I'll solve that the question I have shown, and other questions related to organometallics or group theory. I am thinking to do that. Meenakshi Thakur has raised her hand. You want to ask something?
No, ma'am. It was by mistake.
Oh, okay, okay, fine, fine, fine. Then it's fine. Okay, then we will meet next Thursday.
Thank you,
Okay,
ma'am.
bye,
Thank you, ma'am.
bye. Prepare well. Okay, bye.